So, you guys should already know who I am, hopefully. I'm Taylor Thomas. Just some disclaimers as I start this. I work for Nike. I am not speaking on behalf of them, so better cover my legal backside. The other thing is that, more importantly, I am a Helm core maintainer, but this is not a direction that we've chosen to go and is the official word from the Helm core team. This is me as a Helm community member proposing a feature. So just to make that clear so people don't freak out and think this is what we are doing. So just a quick problem statement for what I'm trying to solve here. Number one, the most important thing is that Helm does not currently have lifecycle application, the application lifecycle management. We've noticed that a lot of people want to use it as a configuration and lifecycle management tool, which we really only have hooks and the wait flag for. The second is that the current tiller model doesn't really follow the ways that have been prescribed for Kubernetes. A lot of people mention that CRDs weren't around, API extension servers and things like that weren't around. There's tons of things that just weren't around when we first created Helm. The next thing is security. Now, this doesn't address all security issues, but as has been mentioned, by using CRDs, we're allowed to use RBAC with those. The last thing, this isn't as important, but it's an interesting point. Right now, if you've ever tried to read a release straight from storage and or modify it, you're talking about a nightmare. So it's something that's a lot cleaner when you get into this. So first, I'm gonna do this as like a tour through the various objects that we'd be creating, the definitions that we'd have, what they would look like, and how the controller would interact with them. Most of these are going to be consumed by a computer, not by a human, but they are very human readable for easier debugging, and also if you want to be really advanced and do something more specific with them. The first and obviously most important, the central object that will be the owner ref of any object created, is the release object. I'm sorry if you can't see it perfectly, but the first thing here, we have manifest values and a secret. This specifies a manifest name that contains, I'll show what that looks like later, that contains the actual manifest that you're going to be populating with the values that are specified, and secrets, so you can store things either as a values in plain text or secrets in actual secret storage. They'll have a service account, just like inside of a pod. It'll be based on whatever RBAC rules are assigned to that service account. And then here's the two big ones. The first thing is dependencies. A lot of people have asked about having release dependencies. I want such and such release deployed before I can deploy this release. This would be a way to do that. It's expecting a Kafka release inside of the foo namespace in this example. The next big thing is Lifecycles, which I will talk more about in depth further down in this presentation. And status is just kind of like a pod status type object that says how things are going. So the controller will function by watching this manifest and any this release object and any specified manifest values or secrets, and if any of those changes, a new release happens, is how that will work on the back end. And so that's the basic functionality of this. The next thing is the values. This is just essentially storage for the values file you give it. There's not much more to explain there. It's just an arbitrary source. Now, theoretically, we could abstract this to a point where we could have any arbitrary value source that is in here. You could point it at some value store, but that's not in the proposal actively, though it could be added. Next thing is the manifest. This contains two parts. If you can't see it very well, this top part right here is the chart. Basically, it's the chart.yaml file. And then down here is the data just all smashed together into a gzipped thing of the manifest. They're not populated with values, it's just the raw manifest to use. Now, the big change here is that we won't be diffing against the manifest that we have stored. We'll be diffing against the live state when we do an apply and do all those things. So those are that'll be a kind of a change from what's now. We're not going to store the whole state of the release in storage anymore. The next thing is the release audit object. This will allow us to maintain something like Helm history. Now, there's some stuff in here. We have this open question of what else should go in here. Right now, I've specified it as a last status and a created timestamp and a superseded timestamp. So when it was done and overridden, and then we just keep pushing those, you have an audit trail of when releases were made and changed. Okay, now this is probably the biggest and most important change in this proposal. Lifecycles are methods for managing the application lifecycle of your release. They're registered with Tiller using a lifecycle object where you specify, it's really simple, you specify an event key, and this is used on a special label inside of an event, which I'll show next, that is used for a controller to consume events when that lifecycle is created. And how it will work is you can create a controller that will handle these types of lifecycles. So you could create, let's say you have a blue-green strategy that you use and you have specific settings for, or canary, and you want, when you're deploying canaries, you want 10% of the deployment to be canaries, or however you want to specify it. You could create a controller, then register a canary lifecycle that you can pass config to, and that controller will handle making sure that those things happen properly. So there will be built-in lifecycles to Tiller. These are the 3 of them. They'll be registered the same way. There'll be objects right here. So these are post-deploy and pre-deploy, which take place of all the pre and post hooks, and then the running hook, or the running, which takes place of the wait flag. Just as a note, we wouldn't break the current hooks compatibility. We'd write some code to do some transparent changing of a hook into these pre-deploy and post-deploy lifecycle objects. And then last but not really, like, we're not going to go over all the different fields here, is the Lifecycle Event. This is the event that Tiller will publish out, and then any of the controllers will need to consume. And you can see just the main part up here is that Helm Lifecycle Event pre-deploy. And it passes in the config that was passed through and has a status of how that event is going. And those are all used to manage where the event is at in the lifecycle. Now, there is way too much here to cover in 5 minutes. I'm hoping to discuss this later. I also have created, this is active, it is out there. This is where the proposal is at and where I'm planning on it living until it either gets rejected and we go with something else, or we accept it and move on. So PRs, issues, anything are accepted here, so we can start talking over how we want this to look. That's all I have. Thank you.